Okay, well, good morning, 8th grade. I hope you are doing well. We are now on lesson 10.9, and we're going to do this in two parts. So this is part one, not part two. We're going to do this in two parts so that we can take it a little slower and really understand what we're doing. So this is on page 439. You want to follow along. Page 439. Okay, so our first definition here, and this is very important, is called an Whoa, I'm just gonna try again here. This is called an independent event. I can't spell for some reason. Independent event. Okay, it's in the bold if you see that. And an independent event is where one event has no effect on another. Okay, where one event has no effect on the other. Okay, now the example I want you to think of is flipping a coin. Okay, think about this. I flip it once, so first flip and then second flip. Does it matter what I got on this one? Like, let's say I got heads. Is that going to determine what this one is? No, right? It doesn't matter. Okay, they could each be heads, they could each be tails. One could be heads, one could be tails, could be the inverse, right? It doesn't matter. Flipping a coin is an independent event because it doesn't matter what you did before that. Okay, so that's an independent event. Think about that. They don't depend on one another. One does not affect is probably a good way to think of it. It does not affect the other. Okay, so if you got that, if you need to pause, pause. This is the opposite, though, is what we call a dependent event. And in a dependent event, basically what happens is one event changes the probability of the other event. Okay, pretty amazing thinking about one event changes the probability of the other. So if you look there in their example, okay, they say event A and they have a little hat, event A. They say, let's say that we draw one name and don't replace. Okay, if we don't replace the name, that's going to reduce how many people are there, okay? Look at that. Look to the right. There's a little box, and it has, like, Carl and all these people's names, okay? Now, it says, draw one and don't replace. Now, how many are there? I'm going to put the right number. There are 6 total. So now, the first one, it says, what is the probability of drawing Ellen's name and then Greg's name? Okay, so only one of these has a little e for Ellen. So what's the probability of drawing her name? Well, that's easy. We did this last lesson. It's 1 out of 6. Yay, we did it. But now think about this. When we draw this, it comes out of the box. Whoa. Now how many are left? 1, 2, 3, just 5. So then what's the probability of drawing Greg's name? Well, Greg, let's say his is this one, G. There's only one of Greg in the box left, but now there's how many? 1, 2, 3, 4, 5 total. 1 out of 5 is the probability of drawing that. So when we say combined, then all we do, so this is Greg is 1 out of 5 here. That's Greg. And Ellen is 1 out of 6. Now, to find the total probability, what's the probability that's going to happen? Total probability, if I can spell that, is we do 1 over 6 times 1 over 5, which 1 times 1, we just go across, is 1. 6 times 5 is 30. So the probability of actually drawing that is only 1 out of 30. Okay, that's a very, very low percentage. Okay, 1 out of 30 that we would draw Ellen's first, and then that we would draw Greg's. But you see how they're dependent? This changed the number total when we took one out of the box. Okay, so that's a dependent event. So let's go over some more examples here. So let's say that I have a little chart here that I'm going to get for us. Oh, sorry, not yet. No chart yet. Just kidding. So let's say that we have that same box. If you look back, this is now on page 440. Okay, and this is example 1. Okay, if you want to follow along, whoa, that is example 1. And in example 1, let's say that the first event, so number 1, we're trying to find the probability of a boy's name. Now, if you count up how many there were, if you go back, there were 4 boys out of 6. So how would we write that? We'd write that as 4 over 6. Okay, again, that's the last lesson. You guys knew how to do that. Okay? I don't know why this thing is stuck with blue pen here. But then number 2, okay, so that's 1, is 4 out of 6. Then number 2 says a girl's name. Okay, but we have to assume that we did draw a boy's name first. So how many girls were there? Well, there were 2 out of the 6 were girls. But think about this. If we did draw a boy's name, so we actually drew it, how many would be total? It would actually be 2. Still, the girl stays the same, but out of 5 total. Okay, hope everybody sees that. So the probability of drawing a girl's is 2 out of 5, and the boys first is 4 out of 6. So the way we come down here is we write 4 over 6 times 2 over 5, which if we don't simplify is 8 over 30, which then reduces to 4 over 15, or if you do it in a decimal, is 0.27, okay? So that is the probability. It's only 27% that we would draw a boy's name first and then a girl's name, okay? So that's a dependent event. It's when one is going to affect the other. Okay, so that's fun. Now, what we're going to do is we're going to do something a little different. I'm going to add a chart here. So they really like these little spinny chart things in our homework. So here comes, we're going to do this one. So here we go. Sorry, this is a little dark, but I hope you can see it. It's on your book at some level. Okay, so now imagine this. We have these 2 spinners. Okay, now let's think about this. These are independent. You may say, why are they independent? Independent. They're independent because this one, spinning that one, does not affect what that one's going to do. Okay, so they are independent events. So in this case, we won't have to subtract the total. We'll just multiply. So let's say that they say, what's the probability of A and 4? What's the probability of A? Okay, so which chart is that? That's this chart over here, the first one. What's the probability of A? Well, A is 1 out of how many? 1, 2, 3. So the probability of A is 1 over 3. And when I see the word and, I make that a multiplication sign. What's the probability of 4? Okay, now I'm looking at this chart. How many of them have a 4? Well, that's kind of easy. Just this blue one right here out of 1, 2, 3, 4. So I come over here, and that's 1 out of 4. So now, to solve that, the probability combined is 1 over 12. Do you see that? 1 over 3 times 1 over 4 equals 1 over 12. 1 times 1, 4 times 3. That's 1 over 12, which in fraction is 1 out of 12, and then we divide that at 0.08. So you can leave it either way, 0.08 or 1 out of 12. So that's the possibility, the probability that we would get an A and then on the same spin get a 4. The likelihood of that happening is only 1 out of 12. Okay, now let's look at another one. Same chart. So I'm just going to erase. I'm just going to erase over here because we are using the same chart. Still an independent variable. Okay, here we go. So what is the probability now of a consonant? So you have to, go back to English class real fast. Consonant and odd number. Okay, an odd number. So first I find the probability of a consonant. So I'm looking at this chart over here. Now, which one of these is a vowel? Okay, the A is a vowel, which means that these guys in blue are consonants. So that's what? 1, 2. So I said that's 2 out of how many? 1, 2, 3. Okay, does everybody see how I did that? That's like last lesson combined with this lesson. 2 out of 3. Remember, the and turns into a times sign. Now an odd number. So I come over here. Is 4 an odd number? Nope. Is 2 an odd number? Nope. So my odd numbers are 3 and 1. So how many is that? 1, 2. So that is 2 out of how many do we have? 1, 2, 3, 4. 2 out of 4. So I multiply that. 2 times 2, which is 4. 3 times 4, which is 12. And if I simplify, that's 2. Sorry, if I simplify, that's 2 out of 6, which is also 1 out of 3. And so when I multiply that, so the probability is 1/3, which is also 0.0, undo, 0.33, okay? 1/3 or 0.33. That's 33% chance that I would get both get a consonant on this side and an odd number on that side. Okay, so that's not too bad. Pretty straightforward. I think you guys actually will do quite well with that. The key part is to get, once you get this step right, when you count, then you just have to multiply and you've got everything else. So you guys know how to do that. You learned how to do this step in green here on our last lesson. So this lesson will be pretty straightforward. We're actually going to take 2 days to do this though, because I want you to make sure that you guys understand it. So I'll do a brief lecture for tomorrow, just kind of going over a few more examples, but really not going to get more complicated than that. Yeah, so it's not going to get more complicated than that. So here is our homework. This is 10.9, which is on page 442. And the homework that we're going to do for that is 1 through 24 all. There you go. 10.9, page 442, 1 through 24 all. Let me know if you have any questions. That's all. Thank you very much. Mr. H is over and out.